I'm going to talk about, give a general introduction to the philosophy of mathematics. And I'm not going to assume any knowledge at all of either philosophy or mathematics. So I'm sorry if it seems a bit basic to some of you. Okay, I mean, the first thing to say, I think, is that mathematics and philosophy, which I think most people tend to think are poles apart, are actually closer than you might think, and a lot of the great philosophers have also been great mathematicians. And I think that's not an accident. I think there's a close affinity, actually, between the two subjects. In several respects, the most noticeable, perhaps, is that both require and demand thinking on a very abstract level. But as I hope to show today, there's a lot more to the relationship between the two than that. And in particular, that mathematics has furnished philosophy both with a model of a certain kind of knowledge and with a set of deep and interesting philosophical problems. But the two go together. Plato knew this. It's said that at the opening of at the gate of Plato's academy, it said, "Let no one enter here who knows no geometry." Interesting, I think, that it's geometry rather than arithmetic. And there's a story there, which I'm going to tell, which is to do with the fact that the ancient Greeks regarded geometry rather than arithmetic as the more foundational, the superior branch of mathematics. And one of the main reasons for that was the unhappy story of Pythagoras. Most of you, I think, will know the name Pythagoras from his famous theorem, which we all learnt at school, which says that the square on the hypotenuse of a right-angled triangle is equal to the sum of the squares on the other two sides. Well, that very theorem presented a problem to Pythagoras and his followers. I don't know whether many of you know this, but Pythagoras was a sort of cult figure in ancient Greece, and he had a band of followers who were dedicated to the mysticism of numbers. It was one of their precepts that everything in the world could be expressed as number, and in particular as the ratio between two whole numbers. Well, now, if you go back to Pythagoras' theorem, it's a consequence of that theorem, actually, that belief is unsustainable. And the reason for that is that reflecting upon that theorem leads you straight into what are called irrational numbers, numbers that cannot be expressed as the ratio between two whole numbers. To see this, imagine a right-angled triangle with length 1 here and length 1 here. So you've got a square on here of 1, a square on here of 1. The square on the hypotenuse, therefore, is going to be the square root of 2. And Pythagoras discovered to his horror that the square root of 2 cannot be expressed as a ratio of two numbers. It's not a rational number. Pythagoras was so horrified by this, he swore his followers to secrecy about it. They weren't allowed to mention the irrationality of the square root of 2. But it did undermine the faith in numbers as the foundational view of mathematics, and that's why geometry is regarded as superior, because in geometry you can express the hypotenuse, you can draw it, but in numbers you can't express it as a ratio. Okay. So mathematics and philosophy have always gone hand in hand. I said one reason for that is that mathematics provides a model of knowledge. It provides a model of knowledge of a particular kind. That's to say, philosophers since the ancient Greeks for over 2,000 years have regarded mathematical knowledge as somehow special and something to which all knowledge could possibly aspire. What makes mathematical knowledge special? Well, several things. One is, unlike other knowledge, it's certain. If something is true in mathematics, and if you know it, you're not going to doubt it. You're not going to say, well, I'm fairly sure that 2 plus 3 equals 5. You know that 2 plus 3 equals 5 with absolute certainty. That's the first thing. The second thing is that knowledge in mathematics seems to be incorrigible. That's to say, it's not going to be corrected by anything you might subsequently learn. 2 plus 3 equals 5 now, 2 plus 3 equals 5 2,000 years ago, and you might say, even if there weren't any people on Earth, it would still be the case that if 2 apples fell to the ground and 3 more apples fell to the ground, then you would have 5 apples on the ground altogether. So mathematical knowledge is certain, it's incorrigible. Another thing is, that's related to its incorrigibility, it's eternal. It's always true. If something is true in mathematics, it's not true for the time being. It's always true and always has been true. And a fourth thing about mathematical knowledge is that it seems that mathematical truths seem to be not just contingently true, but necessarily true. Southampton happens to be on the coast of England. But that's not a necessary truth. It doesn't have to be. I happen to be wearing black trousers. But again, that's not necessary. But 2 plus 3 could not equal anything but 5. It's necessarily equal to 5. So, philosophers have looked at this example of mathematical knowledge, and they've thought two things. One is, how is it that knowledge in mathematics has those characteristics? What is it about mathematics that gives its knowledge those characteristics? And the second thing that's occurred to several philosophers, including Plato, Hobbes, Russell, was, why can't other kinds of knowledge be like that? Maybe we could have a system of physics, for example, that made our knowledge of physics as incorrigible, eternal and certain and so on as our knowledge of mathematics. So mathematics has provided a model of knowledge. On the other hand, it's inherently puzzling. Mathematics has provided philosophers with a number of deep puzzles that we have been scratching our heads over for over 2,000 years. The central one of which is the most basic of which is, what is mathematics about? So if you know that 2 plus 3 equals 5, you know with certainty, incorrigibility and so on. But what is it that you know something about? Well, as I said, if you add 3 apples to 2 apples, you'll get 5 apples. If you add 3 lemons to 2 lemons, you'll get 5 lemons. But 2 plus 3 equals 5 is not about apples, and it's not about lemons. It's applicable to those things, but it's not about those things. So what is it about? Well, it's about numbers. But what are numbers? It's when you ask that question, it's one of those philosophical questions that the more you think about it, the less clear it gets. What are numbers? Numbers seem to be the content of objective truths. If I say that 2 plus 3 equals 5, I haven't just made it up. I'm not getting it from anybody. It is objectively true. And most of the things that we have objective truths of are objects. So are numbers objects? Well, unlike apples and lemons, you can't see a number. A number does not reflect light. You can't smell a number. You can't touch a number. So if a number is an object, it's a peculiar kind of object. It doesn't exist in space and time. It doesn't corrode. It doesn't get old. It makes no sense to ask, what its physical size is, and so on. So if it is an object, it's a peculiar kind of object. It's an object that doesn't exist in space and time. It's not part of our spatio-temporal world. Plato had a theory to account for this, which is the famous theory of forms. According to Plato, numbers are forms, and forms are abstract, objectively existing objects. And the fact that they're not spatio-temporal, they're not part of our world of space and time, didn't bother Plato a bit. On the contrary, it confirmed him in his opinion that reality is formal. The world of forms is the reality of which our spatio-temporal world is but a shadow, according to Plato. And according to Plato, this accounts for the corrigibility of everything we get from our senses. Everything we see, everything we touch, everything we smell, the knowledge we get from our senses is always open to revision. We might look again and see something different. Whereas formal knowledge is not. And what that shows, according to Plato, is the superiority of our reason over our senses. We can't see forms, we can't touch forms, but we can grasp them intellectually. We can get knowledge of forms, knowledge of arithmetic, by thinking. And according to Plato, that explains the characteristics of mathematical truth. It's necessarily true. It's not contingently true. It's not contingently true because it's not about the contingent world, the spatio-temporal world. Now, the downside of this theory, the upside of this theory is that it explains a lot about mathematical truth and mathematical knowledge. The downside is that it requires us to believe in something that a lot of us have trouble believing in, which is an objectively existing world of forms. And even if we could persuade ourselves that such a world existed, we'd have an apparently insolvable problem, which is, how do we, so to speak, reach it? Given that we can't see it, we have no sensual awareness of it. How do we bridge the apparently unbridgeable gulf between that world and us? After all, we do exist in the spatio-temporal world. So for those reasons, philosophers, a lot of philosophers, I would say most philosophers, have had trouble persuading themselves that Plato's world of forms really exists, and therefore that the so-called mathematical realm that was supposed to be part of the world of forms, a lot of philosophers have trouble persuading themselves that that exists as well. And these thoughts had occurred to Aristotle, who was a pupil of Plato's, who didn't believe in the world of forms. He believed that mathematics is not about objects in the mathematical realm. There is no such realm. Mathematics is about our world. And okay, we can't see a number, but we might regard a number as a property of things that we can see. So okay, numbers are not objects, but we can understand them as features of objects. So we look in a field, we see 4 cows. It's not that we see the cows and then we see 4. It's that 4 is a property of that collection of cows that we see. Well, philosophers since Aristotle have put forward powerful objections to that way of looking at numbers, the most powerful of which were put by a German mathematician cum philosopher, Gottlob Frege, who was writing in the 19th century. And he said, look, when we know something about numbers, we know it objectively. But numbers, Frege said, cannot objectively be properties of other things. And the reason, he said, for that is that which number belongs to a collection of things will depend upon how we conceptualize it. So think of a deck of cards. A deck of cards has 52 cards in it. It has 4 kings. It has 4 suits. 4 suits, 52 cards. Depending on whether we have a deck of cards in front of us. Depending on whether we're thinking in terms of cards or of suits of cards, different numbers will belong to that particular collection of things. So does that collection of things have the property 52, or does it have the property 4? It has the property 52 if we're thinking of cards. It has the property 4 if we're thinking of suits. At a simpler level, imagine a pair of shoes. It's 1 pair of shoes, but 2 shoes. So as an object, as a physical object, which number belongs to that? Is it the number 1 or the number 2? So Frege says this is in general true, that objects, objectively so to speak, do not have numbers as properties. They acquire numbers as properties when we think of them in different ways. And this is inconsistent with regarding mathematics as objective. So for those reasons, the idea that numbers are properties of objects is one of those ideas in philosophy that is, by a lot of philosophers, been regarded as being refuted by Frege. We seem to be on the horns of a dilemma where, when we solve certain problems about mathematics, we encounter others. If we do justice to the objectivity of mathematics, like Plato did, we seem lumbered with a kind of metaphysics, a metaphysics of abstract objects. And when we ask ourselves too deeply questions about what these abstract objects are supposed to be and what the world of forms is supposed to be, we find that we can't give satisfactory answers to those questions. Where we can give satisfactory answers to those questions, we seem to be impaled on the other horn, which is we seem to have adopted a view which does away with the objectivity of mathematics.